Okay, let's dive into a story that's a real David versus Goliath tale from the world of AI. It's a story that pretty much challenges a core belief that has driven AI development for years, this idea that bigger is always better. So here's the puzzle that has really stumped researchers. We've got these massive large language models, LLMs, with hundreds of billions of parameters. They can do some incredible things, right? But then you give them something like a Sudoku puzzle, a task any person can just sit down and logically work through, and they just fall apart. They make totally illegal moves. They get confused. It just doesn't work. And this right here, this is the heart of the problem. See, LLMs think in a straight line. It's called autoregressive reasoning. They generate one word, one token, after the next, and if they make one tiny mistake early on, the whole thing can just go off the rails. But we humans, we don't think like that. We reason iteratively. We make a guess, we check our work, we realize, oops, that's not right, and we go back and fix it. And that difference, it's the key to this whole story.
So here's how we're going to break this down. We'll start with this paradox. Then we'll look at the first big, complex attempt to solve it, a model called HRM. Then we'll meet our underdog, TRM, and see how it completely changed the game. We'll get into exactly how its simplicity is its secret weapon, check out the incredible results, and then wrap up by thinking about what this means for the whole AI race.
All right, so the first major attempt to crack this reasoning problem was something called the Hierarchical Reasoning Model, or HRM. This was a really cool idea, trying to give AI that human-like ability to think things through step by step in a very sophisticated, brain-inspired way.
Now, HRM was pretty intricate. With 27 million parameters, it's way smaller than a giant LLM, but it was designed to be much smarter. It had two different networks that were meant to work like different parts of our brain, reasoning at different speeds. The goal was to create this loop where it could refine its own answers. But to make all that happen without being incredibly slow, it had to rely on a big mathematical shortcut.
And that shortcut is based on this thing called the Implicit Function Theorem. Just think of it like this. You have a student doing a long math problem. The right way to check their work is to look at every single step, right? That's called backpropagation in AI. The IFT shortcut is like a teacher who's in a hurry and only looks at the final answer. It's way faster for sure, but you have no idea where the student went wrong if the answer isn't right. And this is where the cracks started to show. A new team of researchers looked closer and found a huge flaw. That shortcut, the IFT, only works if the model's reasoning eventually settles down into a stable, fixed-point answer. Turns out, HRM probably never even reached that stable point. Its entire justification for being so efficient was basically built on shaky ground. And that discovery is what opened the door for our underdog, the Tiny Recursion Model, or TRM. Instead of trying to patch up HRM's complicated design, its creators decided to just strip it all away and build something radically simpler.
I mean, just look at this. TRM is about a quarter of the size of HRM, with just 7 million parameters. It tosses out the whole two-network, brain-inspired thing for one single tiny network. And most importantly, it ditches that complicated IFT shortcut for a simple, straightforward recursive loop.
And to really put its size in perspective, this is just wild. Those 7 million parameters, that's less than 1/100th of 1% of the parameters in a giant LLM. To put it another way, for every one building block in SRAM, a model like GPT-3 has over 10,000. It's a completely staggering difference.
So what is the secret here? How in the world does this tiny little model get such amazing results? Well, the answer is in a few really elegant simplifications that just completely change the game.
TRM's first big aha moment was rethinking what HRM's two networks were even doing. They realized one of the features was basically just the current proposed answer, and the other, it was just the thinking used to get there. It wasn't some complex brain hierarchy, it was just the answer and the thought process behind it. And once you see it that way, the whole process becomes this really intuitive loop. The model starts with a guess, then it uses its reasoning to think about that guess. That thinking helps it update its reasoning, and then it uses that new, better reasoning to refine its guess. It just does this over and over, up to 16 times. Basically, it's checking its own work and fixing its own mistakes, just like we would. And this is the secret sauce, the single biggest change. TRM completely gets rid of that IFT shortcut. Instead, it learns from its entire chain of thought. So back to our analogy, this is the teacher who checks every single line of the student's work.
Yeah, it takes a bit more effort, but it lets the model find the exact spot where its logic went wrong and actually fix it. And the impact of this one change is just massive. The researchers actually tested a version of TRM that still used the old shortcut, and it scored about 56% on a tough Sudoku test. But the final TRM, the one that learns from the whole process, it scored over 87%. That's a huge leap in accuracy, all from one brilliant design choice. So now let's look at the actual results, because this simple change adds up to a truly stunning victory across the board. On the hardest Sudoku puzzles, the results are jaw-dropping. The giant LLMs, they score a flat 0. Nothing. HRM, the more complex model, gets it right 55% of the time. But a version of TRM with just 5 million parameters, it nails an accuracy of over 87%. It's not just an improvement, it's a total blowout. And it's not just a one-trick pony. On this maze-hard test where the AI has to find its way through these super complex grids, the little 7 million parameter TRM, again, comes out way ahead of the much larger HRM. It just proves its smarter way of learning is simply better. Now this might be the most impressive result of all. The ARC-AGI benchmark is this famous test of abstract reasoning designed to see if an AI has flexible, human-like intelligence. And here, our tiny TRM scores 44.6%, beating not only its predecessor, but also a massive state-of-the-art model from one of the biggest AI labs out there. So what's the big takeaway here? Well, this whole thing is a fundamental challenge to that bigger is always better philosophy that's been running the AI world for years. This isn't just about one clever model. It's about a totally different way of thinking. Really, the success of TRM teaches us this powerful lesson that elegant simplicity and deep iterative reasoning can be way more effective than just throwing more data and more power at a problem. It proves that small, specialized models can run circles around the giants by actually learning from their own thought process instead of just taking shortcuts. And this leaves us with a really fascinating question for the future. Are we really heading for a world with just a few massive do-everything AIs? Or is the real path forward an entire ecosystem of small, efficient, and brilliantly specialized models like TRM, each one a master of its own little domain? The success of this tiny model suggests that this race is far from over.